This simulation is going to help us to understand flow rate and how the area of a pipe can be affected, or how the area of a pipe can affect the rate at which liquid passes through a pipe. So here, if you look up here, you have the flow rate is measured in liters per seconds. So what you're calculating is how much stuff or how much of a volume passes by the edge of this pipe here each second. And if we increase the flow rate, so you see there, they're more spread out because the water is moving by more rapidly, so they can travel over a larger distance. So this one has a higher flow rate, more volume passes by per second here. So that's the flow rate. So now let's see let's also measure the velocity. So in this case here, the velocity should be the same throughout this entire pipe because the size of the pipe is the same. But now let's go ahead and change the area of the pipe and let's see what's going to happen. So if I make this cross-sectional area of the pipe larger, you notice that the flow rate drops. And if I make this same area smaller, the flow rate increases here. So the smaller the cross-sectional area of a pipe, the bigger the faster to keep the same flow rate, the particles have to speed up, so the bigger the velocity. And if you make the cross-sectional area of the pipe larger, to keep that same flow rate constant, that means that the velocity has to become smaller. So the smaller the cross-sectional area of the pipe, for the same flow rate, velocity is going to increase. And the bigger the cross-sectional area of a pipe, in order to keep the same flow rate, the velocity is going to decrease.